Okay, good news. I swear, last day of graphing these lines. Okay, this is graphing your systems. This is not the best for accuracy. This method, the elimination substitution is better, especially if your ordered pair is a fraction or a decimal. Okay, so we're graphing two lines on one graph paper, okay, and we're just trying to find out where they intersect. That's what a solution to a system of linear equations is. I know, a lot of words. It's just drawing your two lines, finding out where they intersect, and that intersection is the solution. Okay, there's only three scenarios in the systems. If your lines do intersect, then that intersection's at one point, and you have one solution. Even though it's an x and a y, it's one solution. Your lines could be parallel, okay, they never touch, and there's no solution. And then the one that most people forget is, equations like fractions, they can be multiples of each other, okay? You can reduce equations down. So the equations might look like they're two different equations, but when you go to graph it, they end up being the exact same line. And if they're the exact same line, then all those points are in common, and it's called infinite solutions. Okay, so here we go. We're gonna party on with number one, and we started nice and easy here. Look at this. Those babies are in slope-intercept form. You're gonna love that, right? That makes life easy. All right, so we're gonna graph both of these equations on this graph paper, and we're hoping to find out where they intersect. Okay, so let's look at the top one. All right, the top one, your bank value, your y-intercept is you're starting with negative $6 in the bank account. Oh, that's not good. All right, so you're gonna go down to 0, 1, 2, 3, 4, 5, 6. Here's your point, okay? So your B value is 0, negative 6. Okay, this is for, we'll call this one line 1. And then your slope for your line 1 is you're losing $5 every 3 hours. All right, if you noticed, if I try to go down 5, I'm going to go off the screen. So you can take this fraction and you can move the negative on the 3, okay? In this case, if you do that, you're going to rise up 5 from that point and go to the left 3, but it's still going to be a negative slope. So let's try that. We're going to go 1, 2, 3, 4, 5, but this time we're going to go left. 1, 2, 3. All right, and I'm just going to do it one more time. I'm going to go up 1, 2, 3, 4, 5 over 1, 2, 3. All right, and then I'm going to go ahead and connect those 3 points as nice as I can. You want nice straight lines for this method because you're trying to find out where the two lines intersect. Okay, before I get too happy with this, I had an x and a y, so it should be diagonal. The slope was negative, so it should be falling down. Okay, we're good. All right, now line 2, okay, the bottom one there. You're starting in a better situation. You're starting with $5 in your bank account. Positive whopping $5. Can't beat that. So I'm going to go up to 5 positive. 1, 2, 3, 4, 5. And also your money situation is better. Your slope is better than the last one at least. You're making $1 every 6 hours. Wow, big time. So from here, I'm going to go up 1 over 1, 2, 3, 4, 5, 6. Okay, and then look at this. We can be all fancy. You can make both the numbers negative. Because remember, a negative divided by a negative is a positive, and if you make both numbers negative, look, you're falling down 1, going 1, 2, 3, 4, 5, 6, and then when you connect your lines here, you can see that the solution, we're looking for where they intersect is right here. What was that? Yeah, 6 left, so negative 6. And then 1, 2, 3, 4 up. Very good, okay? So you sunk my battleship at negative 6, 4. The neat thing that you can appreciate about math, though, is this problem is not really anything different from the last unit. The only thing different is we're graphing 2 on one graph paper, and we're just trying to see where they intersect. So, okay, there you go, one solution. You wanna try one more? Okay, let's slide over to number 2. That should be pretty easy for me to be able to slide over there and not mess everything up. Okay, so which line does not have an X? Yes, the top one. Okay, look, this equation is just y equals 5. If you don't have an X, it's gonna be horizontal through that number. Ooh, I like this one. So go 1, 2, 3, 4, 5. And I'm sorry, your life is so that you are stuck making $5 an hour your entire life. That's what that means. Okay? All right, that was equation 1, and that was easy. Okay? Equation 2, this is looking better than all the other ones. Equation 2, in your bank account, your B value, your y-intercept, you're starting with $7. It's the most that I've seen. So I'm going to come up here, 1, 2, 3, 4, 5, 6, there's 7. Okay, we're good so far. All right, and then your money, an hour, you're making $2 every 1 hour. So you're making $2 every 1 hour. If I want to come back and try to hit that line, I can make them both negative. All right, and now I'm going down 2 to the left 1. So right here is where those lines are going to hit. And that location's right here will be what? -1, 5. You can see how this method will be very frustrating, because if you're not right on it, if you don't have nice straight lines, you can't tell. Also, you can take -1 and plug it in for x. If I take -1 and plug it in for x, 2 times -1 is -2. -2 plus 7 is 5. You see it works. And then look, the top equation, you don't even plug the -1 in. You see that? Because it says y equals the y value, so y is 5. As long as this ordered pair works when you substitute it in both equations, you're good to go. Okay? All right, well, this is systems of linear equations. Fun stuff by graphing. Good to see you. Take it easy.